Our main talk this morning, our main speaker this morning is Dr. Verena Kallhoff. I'll be speaking on innovations in surgery in the 21st century. Dr. Kallhoff is the managing director of CYBOR, an industry university cooperative research center sponsored by the National Science Foundation. The center focuses on using the tools of computational surgery to drive improvements in the hospital operating room. In her role, she interacts extensively with researchers, industry members, and all other stakeholders, building relationships and innovative capacity. Dr. Kallhoff received her PhD in human and molecular genetics from Baylor College of Medicine and an MBA from University of Houston Clear Lake. And we're also honored to have her as a member of our board of directors and our community. Houston Oasis, please welcome Dr. Verena Kallhoff.
Good morning, everybody. I think this is the first time that I'm speaking at Oasis about something that relates to my work. And so it's something I'm really excited about. Anything that has to do with science, innovation, STEM in general, and just kind of doing that reach out is something that I'm incredibly passionate about. Absolutely love the work that I do. And so today I'm going to talk about innovation in surgery in the 21st century. Now, when I was getting started on this talk, I figured, well, you know what, let me get started with a lot of background, how that surgery started, and on and on and on. And about 3 days ago, I realized nobody wants to be here for 5 hours. So I decided to cut it down quite a bit. There's just going to be a very brief introduction to surgery. We do have quite a bit of archaeological evidence of surgery having happened about 12,000 years ago already. People just kind of drilling into the skull, trepanation in order to release whatever kind of issues they might have had, setting bones, as well as fixing lacerations and or amputations. However, up until about a little over 100 years ago, there was a lot of risk involved with surgery. First of all, the tools were incredibly crude. We weren't really all that much in tune with, the whole sterility kind of subjects. So secondary infections were incredibly common. And actually, up until about the early 1900s, in essence, you would only undergo surgery if you were pretty sure you were going to die anyway, because you had about a 50% chance of dying after surgery. So those odds have much improved, let me assure you of that. The operating theater about 100 years or so ago was really that. There were a lot of people sitting around, a ton of people typically crowded around the patient, trying to learn from each other and figuring out what was going on. That is not how we do surgery today anymore. We have the field of sterility. We have essentially only those people who need to be by the patient really be by the patient. And by and large, the only area that is exposed of the patient is the area we're going to be operating on. There is a ton of different approaches to surgery. Because I'm going to be talking quite a bit about minimally invasive or laparoscopic surgery, I just kind of wanted to give a brief introduction to laparoscopy or minimally invasive surgery. It's the same thing. Essentially what happens is that typically at least 3 tubes are inserted into the abdomen. So that's when you end up with just having little keyholes of incisions rather than a long incision to gain access to something. One of those tubes that gets inserted has a camera in it, and the other 2 are typically used to insert tools into the abdomen. After the insertion of the tubes, the abdomen gets inflated with either carbon dioxide or nitrous oxide. That's just kind of to expand the space. The field of vision of the surgeon is actually in front of them on a screen rather than looking down, because there's nothing to see other than a few tubes sticking into the abdomen. And then of course there is the open surgery, which is something we're all very familiar with. An incision is made, you're gaining access to that particular area that you want to have access to. Obviously there's a number of surgeries that can only be done in open surgery. If you're trying to do a heart transplant, you're not going to try to do it through a few tubes in the abdomen, quite obviously, I think. And there's a number of other surgeries where you would still use open surgery. However, the use for laparoscopic surgery has by far extended over the last 10 to 15 years, and so there's more and more things that we're learning to do. Part of the problem with minimally invasive surgery is that you don't necessarily have as great of a field of vision that you would typically have with open surgery. However, there's a number of approaches that we can take to minimize the issues related to that, and there's a lot of work being done in that. Many of you may have heard about robotic surgery, and every time I hear that, I kind of cringe, because to me, a robotic surgery is a robot walking in and doing things on their own. That is not at all what's happening with robot-assisted surgery. So the Da Vinci is one of the earliest robots, quote unquote, on the market to assist with surgery. And as you can see, you have over there where the nurse is standing, you have a big machine that will be hovering over the patient. Tubes coming down, those are the laparoscopic tools. There is a number of different channels. This one I think there's only 3 shown, but it has a lot more channels nowadays that can be inserted into the patient, while the surgeon sits off to the side on a machine, manipulating little things while having in front of him actually the camera image of what's happening, what's going on in the abdomen of the patient. So the surgeon is not actually hovering over the patient like we're used to in surgery. There have been a number of improvements in robot-assisted surgery over the last few years. I think the Da Vinci is in its 6th version now. And they have made huge improvements on ergonomics, et cetera, et cetera. But essentially what is done is that the surgeon's minor little movements are translated to very precise movements within the patient's body. There are challenges associated with it because the physicians who are trying, or the surgeons who are using this equipment, that wasn't available while they were training to become a physician, right? Physicians who are now in their 60s, well, when they were going through training, laparoscopic surgery wasn't around either, right? So one of the challenges with this machine is, how do you train somebody to be very proficient on it? I had a conversation the other day with somebody who said, by and large, when we're training, we're using overripe tomatoes. And if you can suture an overripe tomato to the degree where it no longer falls apart, that's when we start moving on to other things. But it's not one of those things. Are you using fruit? Okay, fine, we'll go for that. Another technological advancement that's come around over the last couple of years is the hybrid OR. With certain surgeries, precision is of utmost importance. If you're trying to resect a tumor that is right next to a blood vessel, you're going to want to know exactly where is the tumor and where's the blood vessel while you're doing that, because you don't want to hit the blood vessel inadvertently and go down the road that you don't want to go down. The hybrid OR is an operating room that has oftentimes a freestanding C-arm, which is what you can see over there. It has CT scanners or MRIs attached to it, things that can just be brought over the patient and during the surgery. Obviously everybody's got to step back. They're not going to be right at that time doing something, but so that you can intraoperatively scan the patient, figure out what has actually happened, because the preoperative image might not reflect exactly. The patient might be just at a very slight tilt compared to what they were during the preoperative imaging. And so you would use a hybrid OR to make sure during the operation that you're still in the right spot. Whenever we do innovation in surgery, we want to improve patient outcomes. Right? That is the utmost goal. If what we're doing doesn't in the end make things better for the patient, then why would we bother doing it? Now, our efficiency, stakeholder satisfaction, i.e. physician satisfaction, making sure our nurses are satisfied, patient as well as patient's family is something that we're concerned about, as well as team proficiency training and overall access to surgery. Those are some of the goals that we're working on. So this is a statement from, 2013. And Johns Hopkins published a study where they said surgical never events occur at least 4,000 times per year. Never events are things like wrong site surgery, things like retained surgical instruments, things that should not ever happen. Now, wrong site surgery is not only doing a procedure on the wrong side of the body, but also doing the wrong procedure, doing a procedure on the wrong patient, doing a procedure in a non-sterile environment. And there's a number of fairly simple, very low-tech solutions that have been implemented to that. Most of that is really just team training. You go and identify the patient prior to surgery. That means the surgeon should go meet the patient before they're being wheeled into the operating room, introduce themselves, make sure that the patient verbalizes who they are, of course, if they can. They will also wear a wristband with their information, verify what the patient says, matches what's on the wristband, and matches the folder of the patient that typically travels with the patient. So that's one way of making sure, hey, I know who you are, we both know what I should be doing, let's go ahead and do it. When you're doing amputation or a surgery on a particular side of the body, have the patient point out and label where the surgery should take place, because they're probably likely to know which one of their legs needs to be amputated, right? And then there's something that we call a timeout, and that is really for the entire surgical team prior to surgery to say, okay, stop. Here is what we're doing, here's how we're going to be doing it, and we're all on the same page. Let's go ahead and do it. And this is actually something that comes from aeronautics. I don't know, back in the 80s or so, airplanes were falling out of the sky pretty regularly, and so the airline industry implemented a lot of this stuff. To the degree where when the airplane came down in the Hudson a few years ago, the decision to come down in the Hudson had been made 10 minutes before takeoff. That means the bird strike hadn't even occurred, but the pilot and co-pilot were sitting there and said, if we get hit before we are at 10,000 feet altitude, we're going into the Hudson. So when the bird strike happened, they both knew exactly where they were going to go. They didn't need to confer. They just knew what to do. And that is something that we're trying to do in surgery as well, because things happen. We don't have the standard patient by and large on the table, right? So we talk about things ahead of time. Retained surgical instruments is another one of those never events. This should never happen, but it does. The incidence is somewhere between 1 in 5,500 to 1 in about 18,000. Part of the problem is that this stuff doesn't necessarily get to be reported, but there's a very high complication rate that goes along with retained surgical instruments. Part of the solution to that is, again, very low tech. You count what you have before you start your surgery, you count what you've taken out after surgery. If those two match, well, that's great. Now, I don't know about you, but I, on occasion, don't count particularly, correctly, I guess. I don't know. I miss things, especially if there's other stuff going on, things distract. So another thing that's been done that came out of Kaiser Permanente's Innovation Institute is that essentially they were using something like a jewelry organizer. They're pre-surgery, they had their jewelry organizer, had everything in there. Post-surgery, they had their jewelry organizer and had put all the used things in there. Because when you think about sponges, well, sponges get full of blood and they get lost, right? So it's fairly easy to miss something like that. Well, but if you know you need to have all of these little pockets on your organizer filled, and not all of them are, then you know you need to, before you place the patient, you need to take another look. Another thing that's being done now is RFID tags on the instruments. There have been a number of iterations that have come out of the innovation space. Many of them still require some type of mechanical intervention, or where somebody actually has to kind of lead a wand over it to make sure everything's there. And tagging sponges is fairly difficult. However, I just went to a talk over at TMCX during the demo day, and there's a company that said, nope, we can't tag at all. We have a full handle on this. They're in startup mode right now. So I'm hoping that's going to be something that's going to hit the market relatively soon. One of the things that, that the group that I work with is very much concerned about is efficiency in the operating room. A patient, actually, the patient comes in to the surgery, they get into admission, they go into pre-op. This is where the surgeon identifies them. Then they go into one of the surgical rooms, only to go back out somewhere into recovery and discharge. So there's a lot of different steps that the patient undertakes, right? And if you're running an operating room suite that has 20-some odd ORs, it's really, really difficult for you as management to try to figure out at what stage is every single one of these ORs. Has the patient entered? Have they started surgery? And you don't want to be running into all of these ORs, sterility and the whole thing. So one of the things that the team that I work with has worked on is to essentially put in a ton of sensors around the OR, just, they're hanging out, they're not tagging people, but they sense, okay, the bed is entering now, the anesthesia machine is starting up, okay, so now they've started the first incision because they dimmed the light to go into laparoscopic surgery, okay, they, brought the light backs up, anesthesia machine stopped, the bed went back out. So that gives us a few points already. And then one of the biggest things is, well, the room needs to be cleaned between every operation, right? And if the cleaning team doesn't know for 50 minutes that the OR is ready to be cleaned, there's going to be a delay right there, right? And so this kind of measurement is what we're using to figure out, can we inform the OR management team? Can we give them data in a format that they can easily process and use for decision making and, increase efficiency within the OR, which might allow for that additional surgery to happen in a day. And it might allow people to get out before they hit overtime, right? Time in an operating room, every minute costs about $100. So if you can use it more efficiently and don't have large lag times, that is something that means a lot to the hospital. It means a lot to the patient if they don't have to just be hanging out in pre-op or have their surgery canceled on them, right? And then this is something that I kind of touched on before. The training. There's a lot of new procedures, a lot of new tools. There's, of course, continuing medical education requirements that the surgeons have, but they are being measured by their RVUs, by their productive units. Unlike nurses, they don't necessarily get the free time to do this type of training, right? And so how do we make sure that we train them to be very proficient at what we ask them to do in the hospital operating room? Now think about somebody who is a surgeon in a hospital in Beaumont. They're coming to training, they're learning the newest techniques, the best tools, etc., etc., and then they're going back to Beaumont. They have tried these techniques maybe 3 times on a cadaver. And now they're in their own operating room. They're the only one in there that knows how this is supposed to be done. What are they going to do? Are they going to use the procedure that they have done 300 times with about a 95% success rate? Or are they going to use the procedure that they just learned and have never done on a patient? So what we do with that, one of the cool things is telementoring. And this is physician-to-physician mentoring, where the physicians have trained with each other, the mentor and mentee have worked together during training in the facility, in the state-of-the-art training facility. And now the surgeon goes back to their own hospital, and the mentor is there on a screen, on this little thing right here. And by that time, they have developed a very defined set of communication tools. Keywords to say, stop, look at me, let's figure out what's going on before we proceed. Don't be fiddling around while we need to be talking. And so that is something that's actually very useful to make sure that the surgeon, that the mentee now feels very proficient in using that new technique. And when you think about it, there is a huge rural-urban divide in health outcomes. Right? People here who have access to the medical center have a lot different health outcomes than people who are sitting down in the Texas Valley
who literally have to take a couple days off to go see a specialist. And so we're hoping that as this kind of improves and proceeds, that we'll be able to help rural physicians, consulting them, helping them through particularly difficult surgeries that otherwise they might want to refer that patient to the medical center, but the patient says, you know what, I have several kids at home, I'm helping out my family, I can't take time off. So they might defer. Otherwise, they might just not get the treatment. Well, you know, if those are our options, then we need to do whatever we can. And in addition to that, we're going up to Mars at some point, right? We're not going to be sending every specialist with them. But this way, we have an opportunity to potentially train on the spot whenever we might need to do that. It's actually something, it's kind of arisen out of something that NASA already does. They don't send big volumes of manuals up with their astronauts anymore. The astronauts have something similar to an iPad that they point at the thing that needs to be serviced, and it reads what we're looking at, and it starts walking you through the different steps of serving a particular piece of equipment. There's no reason we cannot work towards making that possible for surgery as well. Now, our approach to innovation is really that we're working with an incredibly multidisciplinary team. We have, on our team, we have 2 surgical residents. We have a couple of surgeons who are there on a referral basis, essentially. I mean, they work with us. We develop a lot of the projects with them. We have industry members on our team that act as mentors. And we have people in electrical engineering, people in biomedical engineering, people in mathematics, and various other arenas. Whatever we need, we pull in because we don't believe that we can answer all the questions. In addition to that, whenever we're developing something, you know, the version 0.0, then we run over to see the people in the operating room, see the surgeon, not inside the operating room, but, you know, the teams that work there, the stakeholders. We interact with them and ask them, hey, what did we come up with? What do you think about it? And there was actually one thing we were working on, and they're like, that doesn't work for us. Okay, well, how about we do it this way? Yeah, that gets a little bit better. You know what, if you can do that, could you add this, and this? And through that process, these teams actually become stakeholders within it, and they start championing this type of technology, and it aids in technology adoption when we then want to transfer it into practice. Another thing that we do is called multi-scale modeling, where you really look at all the different factors that could be impacting it. One of the easiest places to explain that is when you're looking at stent design, stents that are being inserted. In this case, it was into the esophagus. If somebody has esophageal cancer and you want to kind of pull the esophagus aside, well, what happens with these stents oftentimes is that they start moving down into the stomach. Now, that's not a good place for them to be. So there have been things like, oh, well, we're just going to tie it to the nose bone, or, you know, some things like that. And, well, our team went in and was like, well, why did these stents slip? And it turns out that what the engineers in the company had looked at before weren't the appropriate forces. So our team went in and looked at the forces exerted by the muscles contracting, by the muscular motion down, as well as fluid going through. So there's a lot of different factors they took into consideration. Came up with a model, and it turns out that the company was able to use that to make sure that their stent design improved. Obviously, innovation is something I'm incredibly patient about, and I'm passionate. Goodness, not patient. I'm not patient. But so what's been happening in Houston is when I first moved to Houston 13 years ago, there was this incredible medical center, 50-some medical institutions, everybody doing really state-of-the-art everything, research and all of that, but the innovation piece was missing. There was nowhere to go. So by and large, when you develop something in the lab, from that point on, it went either to the East Coast or it went to the West Coast to be developed. It was licensed out, and that's what it was. Well, about 5 years ago, people in the Texas Medical Center said, well, that's kind of stupid. Why don't we build our own innovation hub here? And so you might be able to see it a little bit in the background. What they're thinking about doing now is building this building dedicated to innovation, a huge helix-looking thing taking away one more parking lot around the medical center, but you know. But what's already happening is that TNCX is there, that people are being brought in, startups are being brought in to develop their idea into something that's feasible to actually start testing, right? So TNCX, they bring in the cohorts, they have a curriculum, they have space for them to work on. And TMC Biodesign just does something for a similar thing for something else. JLabs, we actually have an Oasian that it has been accepted to JLabs, part of a startup incubator as well. They allow you access to a lot of different materials and machines that otherwise you wouldn't be able to access because you don't have the money to buy a $400,000 ultrasound or whatever you might need in order to do your experiments and kind of get it to the point where you can go a little bit larger scale. You don't have that money when you're a startup, right? The AT&T Foundry kind of is also there. It's sponsored by AT&T, and they look more into designing healthy homes, allowing people to stay in the home a lot longer than they otherwise would. This CDI, the Center for Device Innovation, is going to start up in October. Billy Cohen, one of the very prominent physicians in Houston, is going to be heading that. Then there's the Houston Technology Center, which is something that has done a lot of innovation and support of startups in the oil and gas industry. They've been doing life sciences as well, but just not on mass scale. And Station Houston is there as well. They're located closer in downtown Houston, and they really are just that incubation space to bring together a lot of the people that you might need. If you're building a startup, you might need somebody to build your website or a code for you, et cetera, right? And so they kind of try to bring all of these bits and pieces together. Now, one of the challenges in Houston has been to get the funding. Venture capital is incredibly important in this, right? Because if you're, where are you going to get the money as a startup? You don't have a product to sell yet, but you need money in order to develop the product. So venture capital is something that really, lots of people are really working on to make sure that the Houston community understands what this is, understands that the biomedical space is very different from oil and gas, which is where we've traditionally done venture capital in, and really support and bring this medical innovation space to fruition. And when I saw this picture online, Futuristic Surgery, I know there's something wrong with this because somebody's still having their hands on that patient. I think in a couple hundred years we're not going to need that anymore. The surgeon's going to sit in Hawaii manipulating some kind of robot while the patient's somewhere over in Washington being operated on. Well, we'll see, right? So that's pretty much my presentation. If you have any answers or ideas or questions, let's go for it. Thank you.
We see in movies a lot of times about surgeons who start getting trembling hands and they're worried about their career. And my question is, with the innovation of these surgical tools, the one machine you showed at the first screen,
the Da Vinci?
Da Vinci, does that help the surgeon be more, or will it help be more forgiving for the type of surgery where a surgeon has that kind of problem?
So I am not 100% certain in how far that will actually, whether the code is programmed in such a way that it'll eliminate trembling. I'm assuming that might have some accommodation for that. But to be honest with you, if a surgeon is trembling, the robot, the Da Vinci will certainly eliminate some of that problem just because it translates larger movements into smaller movements, right? I mean, it's a very different precision that the robot is able to do. But I still think that if you have a surgeon who, starting to have trembles on a larger scale, is probably not going to be the one who should be using that equipment and should be doing. Yeah.
Hey, Josh.
Hey, that was fantastic, and I actually had a ton of questions, but I'll leave most of those to talk to you individually afterwards. But the two things I just wanted to ask with the mic, how is the U.S. doing innovation-wise with this kind of stuff versus the rest of the world? And secondly, when you talk about venture capital and these procedures, and you're talking about licensing, obviously, okay, you can sell a machine, but like an actual procedure, can you patent a procedure? And then, like, if you're developing these kinds of things, is there any profit incentive which they can go and monetize in order to go and use that, if I'm making sense?
Yes. So let's answer your first question first. Innovation in the European market. One of the challenges we have is getting things through the FDA, right? Certain types of devices have to have FDA clearance, and that takes a while. That takes a number of different tests. In addition to that, a lot of the hospitals seem somewhat hesitant to sign up for trials. They're not that used to doing things that might be of risk, right? They're fairly risk averse. So at times it seems to be easier for us to go abroad and test our equipment somewhere else. I know the sensor system was that the team in Houston that I work with developed actually went live in Strasbourg at Strasbourg University Hospital prior to going live in Houston as part of a trial. And then the second part, venture capital and IP. So for a procedure, I'm not sure. I suspect there is not a whole lot you can do to patent it, but what you do is you do that procedure with very special tools that you can't patent. And so, yes, at that point, there's certainly some sort of payout for venture capital investment.
Something I've always worried about, something I've always wondered about medical professionals in general, because I think this is something I would struggle with if I was in the shoes. In dealing with medical liability when something goes wrong in surgery, how do they determine whether or not, okay, the doctor or whoever was performing the surgery just flat out did the best that they could with the training they had and with all the information they had at the time and what they honestly thought was right at the time, and just let that doctor or person be human, we're all human, versus versus this was a clear case of clear negligence and there needs to be serious liability. How is that determined? And quite frankly, how do surgeons that perform surgery in medical procedures not a nervous wreck all the time when they go like, because I'm afraid I would be.
Well, so the surgeons are certainly incredibly resistant when it comes to stress. They deal with it very, very well. And when it comes to medical mistakes, all of that will be determined on a case-by-case basis based on the medical record. Right, and so during the surgery, oftentimes the nurses will take notes that then become part of the patient's medical record, and that is what will be used in the court of law. But of course, there is also with tort reform, there have been limits applied to liability. But I mean, all of that would be based on the patient's record as well as conversations prior to surgery and conversations with the family afterwards, or the patient afterwards.
So with the Da Vinci, it looks like you have a great setup for creating a training simulation.
Mm-hmm.
What are your big roadblocks there?
You know, to be honest with you, with the Da Vinci, there's not a whole lot of roadblocks. The MIGHTY, which is the Methodist Initiative for Technology, Innovation, and Education. It's a center, it's a state-of-the-art training facility within Methodist. There's a great setup. Now, the problem with the Da Vinci is, if you have the trainee in the console, they see what's on the screen, but where's the mentor, right? They don't see what the trainee sees. They don't see what the trainee does. And so that's a challenge, but what Da Vinci is what they're actually working on is to be able to have a second console,
where the mentor could sit, see exactly what the mentee is seeing, and also see whatever the mentee is doing during the training, et cetera, et cetera. So that's something that's being worked on. I mean, in terms of challenges in education, much of it is really how do we do the readout of making sure the surgeon is actually proficient, right? They say they are. We can give them a multiple choice test, but really, what does that measure other than that they've read the book? And so it's really, can we, based on brain waves, eye motion, using eye trackers, et cetera, can we figure out whether or not the trainee is at a point where they're comfortable enough and confident enough to do this on their own and do it on a live patient?
Well, speaking of training, you alluded earlier to the aviation industry, and for several years they've been using flight simulators in maintaining not only basic training, but in maintaining proficiency.
Yeah.
Pilots every 6 months or so re-certify with a mentor, and they can set up different situations. They can even rehearse situations in advance. I'm wondering if there is any movement towards using simulators with the Da Vinci.
Well, not only with the Da Vinci. Yes, the short answer is yes. Actually, there's a huge movement within the surgical arena or the medicine in general to start using a lot more simulators. So when you look at mannequins from 10 years ago, they're very simple. You might be able to put in an IV. By now, the mannequins will do everything. They'll start yelling at you, they'll start convulsing, they'll throw up, they'll do anything a patient, or much of what a patient would do. I actually went to a simulation conference just a couple months ago, and it was quite fascinating, all the different tools that they had in order to be able to train people as though this was like a real life. And you're right, it comes actually, the impetus comes out of the airline industry. I went to a number of different talks at that conference where we had people from the airline industry saying the culture in the 80s was not that of a team going up in the air. It was the pilot was God and the co-pilot, they weren't working as a team. Nobody wanted to speak up against the pilot. And so there was a huge culture change because insurances, as well as the companies flying those airplanes, essentially saw themselves going towards the path of losing a Boeing 737 every other week. And that obviously wasn't going to be good for business. So they put in a huge push towards this culture change, towards making sure that people worked as a team. There were a number of little anecdotes that they were talking about, and one of them was that there was a pilot, co-pilot. They were flying over to Alaska. The pilot was beating up on the co-pilot the entire time, and by the end, they were getting into Anchorage, and the pilot took aim on the taxi strip. The co-pilot didn't say a thing. What was he going to do? He was just going to get yelled at again. They landed on the taxi strip. Nothing happened. But the co-pilot just didn't. It's a culture issue. You cannot have one of your team members that beat up on the others because you're not perfect. You need your team to be able to work together. So, yeah, it's working on it.
So you mentioned a bit of the advent of laparoscopy and this kind of machine-oriented surgery. How do you see the OR kind of evolving over the next 10 years? Do you think that's more kit in the OR, or is that more so on the kind of training side?
So one of the challenges with going very high-tech in the OR space is the cost, of course, right? One of those hybrid ORs is several $1 million. Several organizations within the TMC do have hybrid ORs, but a rural hospital or a hospital in Victoria, Texas is not necessarily going to be able to make that type of investment. And so I know companies want to push very much for very high tech. Our team is taking the approach that we need to make high precision possible at a relatively low cost. And that's going to happen through a lot of mathematical modeling. It's going to happen by us being able to use relatively low-cost inputs and giving the same type of high precision, high fidelity output that we're becoming used to. Because, I mean, the hospitals aren't the ones making a huge profit right now. It is the insurance organizations, and many of the rural hospitals are really struggling to make ends meet. They're not going to be able to buy a Da Vinci, nor are they going to be able to afford the training, setting their surgeons aside for training. So I don't have a crystal ball, but I suspect there is a cap to how high tech we're going to go. Much of it is going to be a push for better training, more consistent training, and training methodologies that actually allow us to know when the physician is ready to do it on their own. Thank you very much.